So our next speaker will be Elsa Boudard from ESPCI that will be speaking about sampling body odor from healthcare monitoring, not so easy to control influential factor. Elsa, the floor is yours.
Thank you. Thank you. So hello everybody. So as we introduced me, I will talk today about sampling body odor for healthcare monitoring, and I will mostly focus on the fact that it's not so easy to control influential factors, but still it's very mandatory. So firstly, to introduce the subject and set the context, we can start to wonder why study body odor for healthcare monitoring. It's because body odor is a very complex matrix, but still a matrix source of plenty information. This is why we can subdivide it into three main categories. The first one is the primary odor, which is stable over time because linked to genetic parameters. At the opposite, we have the tertiary odor, which is exogenous because linked to parameters such as cosmetics. And in between, there is this secondary odor, which is endogenous, but also influenced by external parameters such as food or pathologies. So this is the part that we are interested in. But why exactly focus on secondary odor? It's because pathologies, such as diabetes, will have an influence in our metabolic activity. This will induce changes in the different chemical reactions that happen in our cells, and some molecules will result from this. Some are already known, and they are called metabolites, and will end in already well-known matrices. But some others will cross the surface of our skin, and as soon as they are outside our body, they become part of our body odor, or they will influence it. So, thanks to a training, dogs became able to detect those changes, and so they detect the pathologies. So here we are trying to do the same thing thanks to analytical chemistry, but also we are trying to find the link between the How exactly are we going to proceed? As I said, body odor is a complex matrix. It contains more than 500 compounds at ppm or ppb level. So here we will try to trap the VOCs coming from the body odor on a sorbent phase. Then we will put this sorbent phase on an empty Thermodesorption tube. As I said, we have a complex matrix, so we need a high sensitivity and a high peak capacity. So we will analyze it thanks to Thermodesorption and GCxGC tough emits. All of this in order to validate the canine detections by determining olfactory biomarkers of pathologies. Before doing all of this, we need to sample the body odor, and it's not that easy. So how exactly we can sample the body odor? To do that, we decided to go back to basics and to design a sampling device. We divided it into three main parts. Yes, the sorbent phase, the main part, because this is the one that will trap the VOCs. Then a support to hold the sorbent phase near the skin, and a fastening system to keep everything in place. This sampling device needs to be easy to use with minimum handling in order to avoid contaminations. It needs to be transportable and adaptable to hospital constraints, as something will be done here. And also for the patients, it needs to be comfortable. So firstly, we decided to focus on the sorbent phase, and we studied three different ones. We studied them to obtain their blanks by thermodesorption, and we did it like 20 degrees below their maximum operating temperature. So for the compressed, we obtained 625 compounds. For the power sob, we get 13 compounds, and for the get sent microtube, 38. So at this stage, we were already able to sense that power sob was the best option. But I was a bit surprised because in the literature, compress is the most used sorbent phase. So I decided to compare this blank of the compress to the representative body odor sample. And at this stage, I saw that it was really unusual. Compress is really unusual in this case because it already contains more compounds and at an equivalent or higher intensity. So we also understood that it was really important to characterize the sampling system's own emissions. To do that, the first really important step is the conditioning step of the sorbent phase. So as we decided to choose the power sub, we decided to condition it thanks to heating, so at 220 degrees for 2 hours and with gas flow. It allowed us to eliminate 700 compounds, so it was really, really important. This step was repeatable, so it was a good thing. But at this stage, at the beginning, it was really long because 2 hours, it was the time that was needed for only one power sub. So thanks to the tube conditioner of Mars, we were able to condition 20 power subs at the same time. After that, it was important to choose our sampling conditions. So we started with the friction sampling. Unfortunately, it gave us unusual results with many saturated peaks, and it was mainly composed of fatty acids, so things at the surface of the skin. So after that, we decided to experiment passive contact sampling. It was a bit better, but still with many saturated peaks. And finally, we tried the contactless passive sampling, which gave us good results, but it was also a good way to simulate what the dog can sense. So we decided to use that sampling technique. So in order to be contactless, we needed to have a support to hold the solvent phase near the skin without touching it. So I tried different materials because I also wanted to have a few emissions coming from that materials. So at first, glass and inox gave us good blend quality. It was also repeatable, but unfortunately, they were not at the right size and shape. So I decided to try the plastics. PPAB was the best solution because we can see here there is few plastic emissions, but it was still better than the other plastic that I tried. So finally, we needed to have a fastening system to hold all those parts. The first one that I used was the stretch go strip. It gave us the best blend quality to this day, but it was an unstable fixation. So we knew that fixation containing glue was better, so we tried them, but glue is also a major source of contamination. So as you can see here, it was unusable also. So finally, we got a system composed of power sub, PPAB box, and stretch go strip as fastening system. So we were able to get real body odor at the laboratory. But unfortunately, again, when sample came back from the hospital, we understood that people that were untrained wasn't able to get the same result as us. So it was really important to have an easy system and also a stable fixation, because otherwise we get all contamination coming from the ambient air or something else. To conclude, all this work emphasized the necessity to take into account the emissions of each element of the sampling device in order to have reliable results. Here, I saw that the sampling device made with power sub, PPAB box, and stretch go strip works, but still needs to be improved to be better, to have reliable results too. Also, a clean device will facilitate the data processing and the exploitation of the data, because it could be it can be time consuming, but if you don't have contaminations, it's easier. So finally, there is a need to have a simple device with a stable fixation and minimum ending, as the sampling will be made in hospital and people don't have many time and are not always trained. Thank you for your attention.